This session is on bisection method. It's a part 3. Please look at part 1 and part 2 for better understanding. We will look at how to find the roots of an algebraic equation by bisection method, how to derive the formula, and we'll be solving few problems on it. Please like, share and subscribe this particular channel. Now in this session, I'll be explaining about the bisection method, how to find the root of a continuous function by using bisection method. Okay, if you consider a graph here, this is an x-axis, this is an y-axis, right? And there is a continuous function f of x. And this particular point where it will be meeting is nothing but alpha, which is nothing but root of a function, such that f of alpha is equal to 0. Then alpha is nothing but root of a function, right? Now by using a bisection method, how to find the root or alpha value. Now for this one, I'll be explaining you step by step. Okay. First, what you do is nothing but consider two values, a and b. There are two intervals such that f of a into f of b should be less than 0. Okay. Now if you consider a value here, this one is an a and this one is an b. There's nothing but a straight line. Okay. And this is also in a straight line. Now will be second step, what you do is nothing but find the average of this particular two intervals. Then x1 is equal to nothing but a plus b by 2. Okay. If we get the value of x1 here, okay, then what you do is nothing but multiply f of x1 into f of b. Okay, it will be less than 0, or f of x1 into f of b can be greater than 0, right? Now what we do is nothing but if it is less than 0, then we'll be finding one more value, x2, which is equal to nothing but x1 plus b by 2. Else x2 will be equal to x1 plus a by 2. Okay. The third step, what we do is nothing but find the value of f of x2. We got an x2 value. Say x2 value we got it here somewhere. x2 here. Then f of x2 into f of x1 should be less than 0. Okay. Then we're defining the x3 value, which is equal to nothing but x1 plus x2 by 2. If f of x3 is equal to 0 or approximately equal to 0, then alpha or the root of a function is equal to nothing but x3. Okay, this is a method of finding the roots of a function by using a bisection method. Now bisection method in the form of note I've written it. Okay, it is given that f of x should be in a continuous function and f of a and f of b should be in opposite direction. And to find the value of alpha or root of a function says that f of alpha is equal to 0, we know is in a bisection method. General formula that we know is nothing but x of I plus 1 is equal to a plus b by 2, where I is equal to nothing but 0, 1, 2, so on. Okay, which is equal to nothing but x of n only. Okay, now a and b are two starting values or initial values to find the roots. The basic note part you have to remember is nothing but bisection method depends on acceptable errors. Okay, then error gone by 1 by 2 for every interval. Okay, by 1 by 2, every 1 by 2 the error will be changing. Error is given as b minus a mod by 2 power n. N is nothing but number of iterations. Okay, then number of iteration n is equal to log 2 base 2 b minus a by number of errors. Okay, e. This is a basic note you have to remember for the bisection method. Now we'll be solving few problems on it. We enter the question. The question is, the bisection method is applied to compute a function f of x is equal to x power 4 minus x cubed minus x squared minus 4 and 1 to 9. The method converts to a solution in dash iteration. It's saying that number of iterations are required to find the root of a function. we have to find the value of an n, simply to say, right? Now we'll be understanding with this particular question in better way by using a graph. If you consider a graph here, this is an x-axis, this is an y-axis. Okay, I have taken in a chart. Okay, in a sample. Okay, it's not the exact value. Then this is a function as f of x. Okay, I have drawn it by a sample. It's not an exact graph of a function. Okay, now they are taking in two intervals, 1 to 9. Right. Now we have to find the value of an alpha. Alright, such that f of alpha should be equal to 0. Right. Now by using a bisection method, we have to find it out. They're given that f of x is equal to nothing but x power 4 minus x cube minus x square minus 4. Right, and they're given the interval from 1 to 9. First, what we do is nothing but find the value of f of 1, which is equal to nothing but 1 minus 1 minus 1 minus 4, which is equal to nothing but minus 5. It is a negative value, right? And f of 9, which is equal to nothing but 9 power 4 minus 9 cube minus 9 square minus 4, right? Which is equal to nothing but it will be getting a guarantee and a positive value, right? Now we're defining the first value, x of 1, which is equal to nothing but 1 plus 9 by 2, which is equal to nothing but 5. Next, what we do is nothing but find the value f of 5. We got the value of 5 somewhere here, okay, which is equal to nothing but 5 power 4 minus 5 cube minus 5 square minus 4, right? We get it as 625 minus 125 minus 25 minus 4 minus 625 minus, we get as 154, and 1, it becomes 7, it's 4, which is equal to 471, which is nothing but a positive value, right? Then we have to find the next value, right? Next iteration, then it should be between 1 and 5. So if you multiply f of 1 into f of 1, it will be getting a negative value, right? As we know that f of 1 is nothing but negative value, f of 5 is a positive value, right? It will be a negative value. Then we'll find the x2 value, which is equal to nothing but 1 plus 5 by 2, which is equal to nothing but 3. Then find the value of f of 3, which is equal to nothing but 3 power 4 minus 3 cube minus 3 square minus 4, which is equal to 81 minus 27 minus 9 minus 4, right? This becomes 40 minus 81, it becomes 41, which is equal to nothing but positive value only, right? So it's getting 3 somewhere here again, right? So what we do is nothing but f of 1, when you multiply with f of 3, we will be getting a value in a negative value, right? It will be less than 0. So we'll be getting x3 value is equal to nothing but 1 plus 3 by 2, which is equal to nothing but 2. We're defining the next iteration value. Then we're defining the value of f of 2, which is equal to nothing but 2 power 4 minus 2 cube minus 2 square minus 4, right? So we'll be finding the root, which is equal to nothing but 16 minus 8 minus 4 minus 4, which is equal to nothing but equal to 0. So we got the f of 2 is equal to nothing but 0. So alpha is equal to nothing but 2. Root of a function is 2. The number of iterations required is nothing but 3. So at x3 we got a solution. So number of iterations is nothing but 3. Answer is 3.